Today I'm going to talk about our paper with the title Cascaded H-bridge 7-level inverter application for air exhaust fan drive control of the Thu Thiem road tunnels. Authors include Dr. An Thị Hoài Thu Anh, Dr. Trần Hùng Cường, and Dr. Trần Văn Khoi. The paper comprises four parts. The first part, abstract for paper. This paper proposes a 7-level inverter to feed the exhaust fan drive motor. Its purpose, improving the output voltage quality and the output current and voltage for large power motors up to several hundred kilowatt and kilovoltage level that are difficult to achieve with conventional inverters. Application to Thu Thiem road tunnel in Vietnam to supply fresh air through exhaust fan. Its meaning ensuring health and safety for traffic participants at Thu Thiem tunnel in Vietnam. Yeah, all of it is proved through Matlab Simulink simulation software compared to a 3-level inverter. Yeah, I'm going to introduce introduction. As you know, in the big city in Vietnam, Hoai are facing with many problems. Traffic jam everywhere, especially in the peak hours. That's why some road tunnels developed in Vietnam, especially Thu Thiem Road Tunnel, the most advanced modern tunnel in Ho Chi Minh City, Vietnam, is designed to traverse the Saigon River. Inside the tunnel are 6 spaced lanes for two-way traffic, with lane wide ranging from 2 meters to 3.5 meters. The maximum speed for motorcycle is 40 kilometers per hour. White car can travel at 60 kilometers per hour within the tunnel. Look at some picture in the in this slide. Yeah. In this big tunnel, the ventilation system shown in the figure 1. Among equipment, there are 4 exhaust fan in red. Exhaust fan motor is 525 kilowatt and has a voltage of 6 kilovolts. Therefore, multi-level inverters are suitable for feeding large power motors. Multi-level inverter that can generate the output voltage with very harmonic distortion, lower than that of conventional inverters, increasing the duration of power. Semiconductor switches are divided into 3 types: diode clamp multi-level inverter NPC, flying capacitor multi-level inverter FC, and cascade H-bridge inverter CHB. Next slide. We comprise a number of components of 3 types of inverter width and levels. Look at the table 1. Show that a CHP uses the fewest components, and additional H-bridge cell operate at the low voltage, reducing stress on the component and thereby improving the reliability and lifespan of the inverter. The article content focus on 7-level inverter applied to exhaust fan in Thu Thiem tunnel. The next part, we focus on designing control for Cascade H-bridge 7-level inverter. The first part, we analyze the advantage of H-bridge 7-level inverter. So this part, we describe this control structure of Cascade H-bridge 7-level inverter fed the exhaust fan drive system, including the 7H-level inverter fed the exhaust fan motor using is induction motor with the methods flux-oriented control. This control including 3 loops. The first loop we can see, and the exact linearization methods of flux method and speed control loops with PI controllers. Next slide, we also show the figure 3. Look at this figure. This topology of 7-level cascade inverter. The 7-level voltage short inverter phase IM motor include 3 single phase topology. The DC short UDC must be isolated from each other. HAC output connected to output A, B, C of 3-phase balance loads GA equals ZB and equals ZC, and a common terminal earth point N. Is also an isolation point. G is neutral point of load. In this paper, we use phase vector modulation of 3/7 voltage source inverter is conducted in 3 steps. The first step, we should determine the state vector, voltage vector, and corresponding voltage value. Assume that the 3 VDC voltages are balanced and equal to each other. Output voltage on X phase VAN, VB, and VCN can receive one of 7 level plus minor VDC 0 plus minor 2 VDC plus minor 3 VDC. The voltage across each phase of the inverter load equal to in the equation 1. Assuming the 3 phase are load balanced, the voltage across each phase of the load will be equal to equation 2. The voltage vector can represent the 3-phase voltage system in the equation 3. Therefore, we can calculate voltage in equation 4, representing voltage vector in alpha beta coordinate by transform in equation 5. The phase angle of the vector EV is determined in equation 6 theta. Converting the output voltage vector on the alpha beta coordinate system to the Z8 coordinate system into axis Z and X. Create an angle of 60 degrees. The Z axis coincides with the alpha axis. The base unit vector of the Z8 coordinate system is described in equation 7. The linear transformation does not change the vector, keeping the coordinate origin, so vector represent on 2 coordinate system remains the same as follow. in equal equation 8. From equation 7 and 8, we we look at the equation 9 and continue from equation 9. We can calculating easily V alpha, V beta, or V and V8. Replacing equation 6 into equation 10, we have Vg and V8 in equation 11. We keep going. Look at the equation 12, 13, or 14. I can 7-level H-bridge inverter in 3 phases, key A, key B, key C. Belong to integer -3, -2, -1, 0, or 1, 2, 3. And we can calculate the kg and kx, coordinates of the vector on the gx axis corresponding to the position of the standard vector state BEEI, and calculate the neutral voltage VGN from equation 2. Spatial vector representation on the GS coordinates axis for the Cascaded H-bridge 3-phase inverter. 127 standard vectors are the vertices of the sub-triangles, with the numbering of the vector increasing counter clockwise from inside to outside. Yeah. We keep doing. Look at the equation 15 and 16. It is impossible to calculate all the combination of state vector for the hexagonal angles 1, 2, 3, 4, 5, 6 if the number of voltage levels M, K, G, K are determined. We begin with step 2, synthesizing the output voltage vector from the standard state vector, determining the position of the vector phi in the large sector. The calculation becomes more straightforward if the symmetries of the space vector system in X of 6 is used as shown on the vector plane. 3 hexagonal coordinate system G1X, G1Y, G2X, G2Y, G3X, G3Y in figure 4. Look at the figure 4. The output voltage vector will be in one of 3, 6, 6. First, we need to determine the projection of the vector V answer equal to metric V alpha H's plus V beta H's T onto the two boundary vector of the 6 angle by projecting the coordinates alpha beta onto the respective coordinate system G1X, G1Y, G2X, G2Y, G3X, G3Y. Yeah, look at the picture 5. Show algorithms to determine last sectors. In this algorithm, we can determine G, Ij coordinates. Allocating the vector in the triangle formed by the three vertices as a normal vector, representing the standard vector state on GS. On GS coordinates, the vector will form equilateral triangles of length 1 with a 7-level 3-phase inverter having 16 triangles in each sectors. The triangles number in each sector will be numbers in anti-clockwise and inside-out order indicate figure 6 order of triangles in larger sector. We also determine the two coefficient M1 and M2 in equation 18. Based on M1 and M2, determine the vector position in the triangle in figure 6. Synthesis, the output on this vector from 3 nearest reference vectors, calculation of modulation factors. The desired output vector lies in other triangle synthesized from the nearest 3 vectors, which are the vertices of this triangle. This can ensure an excellent harmonics component for the output on this waveform. The calculation of output on this vector is shown in figure 7. Let me see, MG and MS be the decimal parts apart from the integral part of the coordinates VREF projected onto OG and OS axis respectively in equation 19. Look at the equation 20 and 21. And figure 7. We can summarize the output on this vector from 3 vertices vector of the triangle. For example, in equation 20, VR1 can be synthesized from 3 vector P, from vector P1, P2, P3, and similarly, VR2 can be synthesized from 3 vector, P1, P3, P4. The last step, very important, the order, the implementation of the optimal state vector in terms of the switching time. As the last but not least, a simulation result. Look at the table 2 and table 3 show the simulation parameters. Table 2 shows parameter of the exhaust fan motor collected from Thu Thiem road tunnel. For example, rated power and rated voltage or power factor, rated speed, so on. And table 3 parameters of 7-level inverter, for example, parameter DC link voltage, DC side internal resistance per cell, capacitance per cell, carrier frequency, PWM pulse output frequency. And then connecting a simulation on Matlab Simulink for 5 seconds, the set speed gradually increasing from 0 to the rated speed 592 revolution per minute in the range of 0 to 1.7 seconds. It then gradually decreases as shows the figure 8 and the A phase voltage of the 7-level inverter indicated in figure 9. Yeah. The motor speed level are controlled based on the volume of means of transportation passing through the tunnel at the different time of the day. For example, during peak hour, the maximum speed is 582 revolution per revolution per minute, and when while the other time the fan speed is controlled as the lower speed level. And next, the total harmonics distortion TSD of the load current. Yeah, the load current and the load voltage of the 7-level inverter compared to 3-level inverter from figure 10 to figure 13. With the result simulation show that the outstanding advantage of the 7-level inverter. For example, in the figure 10, TSD of phase A load voltage of 7-level inverter is 2.55%. But figure 11, TSD of phase A load voltage of 3-level inverter is 4.42%. Yeah, is more bigger than TSD of phase A load voltage of 7-level inverters. Similarly, figure 12 and figure 30 compare the TSD of phase A load current. In 7-level inverters, there's only 0.42%, but a load current of 3-level inverter is 4.38%. After result simulation, we can lead the conclusion. Road tunnel ventilation system play a crucial role in bringing fresh air into the tunnel and expelling pollution air, ensuring the safety of people inside tunnel. However, exhaust fan motors, large capacitor, and high voltage can cause significant harmonic distortion of the load current and the voltage. Therefore, we have proposed a 7-level inverter to control the exhaust fan motor. The simulation result in the article have shown the outstanding advantages of Cascaded H-bridge 7-level inverter to control the exhaust fan drive system in the Thu Thiem road tunnel. Namely, comparison result of TSD responses of phase A load current and voltage when using 7-level inverter are better than 3-level inverter. Furthermore, the article also proposes a solution for operating the exhaust fan at appropriate speed level according to the traffic density in the tunnel. Acknowledgement. We sincerely thank to University Transport and Communication and Thủy Lợi University for their financial support for our research. And our paper with 25 references. The last but not least, we would like to thank general editor, Professor Thu Thiem, and editing team, and also a reviewer have accepted our paper. Thank you for the listening.